What is RAG, and why should developers know about it? RAG stands for Retrieval-Augmented Generation, a technique that can significantly improve the usability of large language models (LLMs). LLMs are incredibly powerful, but they have limitations. When integrating them into your application, you can't always trust the accuracy of their responses or understand how they arrived at their answers. That's where RAG comes in. RAG addresses these issues by connecting an LLM to a data store. Instead of relying solely on its training data, the LLM can retrieve up-to-date and specific information from the data store. This means more accurate answers and verifiable sources. Let's dive into the problems with current LLMs. One major issue is outdated data. LLMs like ChatGPT are trained on data up to a certain point, so their responses can be outdated. Even worse, it might give an outdated or incorrect answer because new discoveries have made the previous information obsolete. Another problem is the lack of transparency. LLMs don't provide sources for their answers, leaving users to trust the output blindly. Even if the information is accurate, knowing the source would allow users to verify it. RAG solves these problems by connecting the LLM to a data store. When the LLM needs to generate an answer, it retrieves relevant data from this store, ensuring the information is current and accurate. With RAG, you get accurate, up-to-date information and can trace the source, addressing both major issues with current LLMs. This approach allows LLMs to leverage their natural language understanding and reasoning abilities, rather than relying on outdated training data. Now, let's break down the process of RAG in more detail. Prompt generation. The process begins when you provide a prompt to the LLM. This prompt is your initial query or the task you want the LLM to perform. Vectorization. The prompt is then vectorized, converting it into a numerical format that can be processed by the retriever. Data retrieval. The vectorized prompt is sent to a retriever, which searches a connected data store for relevant information. This data store could be a real-time database, document repository, or any other structured data source. Data injection. The retrieved information is then injected back into the LLM. This means the LLM uses this up-to-date data as part of its context to generate a response. Response generation. The LLM uses its reasoning abilities combined with the newly retrieved data to generate a response to the original prompt. Source verification. The response generated by the LLM includes references to the data store, allowing users to verify the source of the information. Using RAG offers several benefits. Avoids the need to retrain LLMs with new data. Provides sources for the data used. Allows the LLM to respond accurately or acknowledge when it doesn't have an answer, reducing the risk of misinformation. However, there are some challenges. The effectiveness of RAG depends on the quality and relevance of the data retrieved. Efficient and accurate retrieval methods, such as vector databases, are crucial. The process must also be quick to avoid latency issues. Imagine you're a journalist preparing to write an article on a specific topic. You have a general understanding, but you need more in-depth information. Naturally, you head to your local library, which houses thousands of books on various subjects. But how do you find the ones relevant to your topic? You ask the librarian, an expert in the library's collection, to help you find the right books. The librarian retrieves the relevant books and hands them to you. While the librarian isn't an expert in writing articles, and you aren't an expert in finding specific information, together, you get the job done. This process mirrors Retrieval-Augmented Generation, or RAG, where large language models use vector databases to fetch key information and answer questions. Let's consider how businesses use RAG. Take a question like, what was our revenue in Q1 from the Northeast? The first part is straightforward for a general LLM to understand. However, the specifics of Q1 from customers in the Northeast are unique to your business and change over time. To answer this, multiple data sources are needed: PDFs, business applications, images, etc. We consolidate this data into a vector database, a mathematical representation of structured and unstructured data, similar to an array. By querying the vector database, we retrieve an embedding that includes the relevant data. This embedding is added to the original prompt. This enriched prompt is then fed into a large language model, which produces an answer with up-to-date and accurate data. As new data enters the vector database, the embeddings are updated. So, when the question is asked again, the large language model generates an answer based on the latest information. With RAG, we combine the strengths of vector databases and large language models to provide precise, timely answers to complex questions, much like the collaboration between a journalist and a librarian. While I'm not an expert in RAG, I hope this overview gives you a good understanding of its potential. If you found this video helpful, please like, subscribe, and stay tuned for more content. Thank you for watching.